Okay, I'm not going to lie, it's deeply disappointing because it looked like NASA's moon rocket, the SLS, was finally getting momentum again, and then right at the end of testing, another issue pops up. And now the whole rocket has to go back to the VAB for more work. And if you've been following the Artemis missions, you know exactly what I'm talking about.
Helium leaks.
And at the same time, NASA has basically had to face the hard reality with Boeing Starliner. And meanwhile, SpaceX is also doing SpaceX things. They're doing their crewed mission, booster landings, and everything's going really well with SpaceX by the looks of it. So what's actually happening with the SLS? And why does it matter? What does this mean for NASA's plan going forward? Let's break it all down for you now. Alright, so let's first talk about the SLS wet dress rehearsal. This is basically NASA running the rocket through a full launch day style countdown, fueling, chill down, and they basically went through everything apart from lighting the engines, of course. And this was their second overall wet dress rehearsal attempt, and importantly, their second attempt in the same month, because the first one didn't fully complete. So going into this one, expectations were a lot higher. They ran terminal countdown simulations. They hit deep into the final seconds. We're talking like T minus 29 seconds, and another run into the 30-second range as well. That's not just random numbers, that's basically NASA confirming that key parts of the launch sequence are behaving the way they should. Automated sequences, tank pressurization, and another big win here, they successfully loaded the core stage with liquid oxygen and liquid hydrogen. Guys, liquid hydrogen is the pain fuel. It's ridiculously cold. The molecules are tiny. It loves to leak and it finds weaknesses in seals. It loves to search for those. So the fact they got stable refueling and the hydrogen issue was sorted, it actually looked like things were improved and everything was going to plan. Also, the Orion stayed stable too, thermally and structurally. So at this point, people were thinking, okay, maybe we're lining up for a proper launch window very soon. But then after the fueling was done, NASA hits a new anomaly. And this one is linked to the helium flow in the ICPS. It's the upper stage that handles the burn that sends the spacecraft on the way to the moon. Now here's the thing about helium. It sounds simple because it's just a gas, right? But helium is sneaky. It can migrate through microscopic imperfections, and diagnosing helium issues is horrible because the system might look fine under one pressure condition, then fail under another. So what actually happened during the rehearsal itself? The helium system behaved normally, but then in the post-testing servicing, when engineers tried to recharge the helium system, they couldn't get the helium back into the vehicle. That's a big red flag because it's not just something didn't work, it's the system isn't behaving repeatable. And if you're going to fly humans around the moon, you can't have this not working properly. So NASA's leadership basically said the potential fault could be in a few places. A final filter between the ground equipment and the vehicle, a quick disconnect interface, or an onboard check valve. And the reason that's worrying is because there was a check valve type issue during Artemis 1. Even though they made corrections for Artemis 2, the fact we're back with helium issues again increases the scrutiny. So now the big question becomes, what happens next? So now, why do they have to roll it back to the VAB? And why this is such a big deal? So here's the reality. You can't properly troubleshoot everything at the launch pad. The pad is for operations, not deep surgery. If you need direct access to the hardware interfaces, internal components, valves and fittings, you need a controlled environment and proper access and proper tooling. So NASA has to roll the SLS back to the VAB, also known as the Vehicle Assembly Building. And rolling back isn't a casual move. You've got to secure the mobile launcher. You have to make everything safe, then roll the entire stack back at the controlled speeds. Then once you're in the VAB, you can inspect, test and replace whatever needs replacing. But the real schedule killer is this. After you fix it, you still have to retest and re-verify, often under cryogenic conditions to prove the fix actually holds up in real environment. So even if they move fast, April's launch window starts looking very optimistic. And lunar missions are governed by orbital mechanics. If you miss a window, you don't just go to the next day, you have to shift by weeks. So now you're looking at the next practical window moving further into spring, and that depends on how quickly they isolate the root cause and prove it's actually been fixed. So yeah, it's very disappointing, but also this is how NASA works. Now while the SLS is dealing with helium problems, the Starliner is also dealing with something even more serious. Alright, so let's talk about the Starliner, and this isn't just a small delay anymore. NASA recently had a briefing and they classified the issue as Category A, which is the highest level. Basically, that means the situation was serious enough that it could have put the crew or spacecraft at real risk. The problems come down to two main things: a helium leak and some of the small control thrusters not performing properly. Now, spacecraft are designed with backup systems. They're built to handle one problem at a time. But when multiple things start going wrong, your safety margins get very small. And the biggest sign of how serious this was, NASA actually brought the astronauts home on Crew Dragon instead. Now that's good in one way because it shows the backup system works. But here's the main issue. If Starliner is grounded while Boeing fixes everything, NASA is basically back to relying on one spacecraft to get astronauts to orbit. And the whole point of the commercial crew program was to avoid that situation. And there's also talk that Starliner might actually do cargo flights for a while instead of carrying crew. But the bigger problem here is confidence. They need to prove the spacecraft works safely and reliably again and again. When you look at that situation, it really shows the difference compared to what SpaceX has actually been doing at the same time. Now let's have a look at what SpaceX has been doing during all of this. While NASA is dealing with delays and Boeing is working through major fixes, SpaceX has been just moving forward. Crewed missions are launching, docking with the space station, swapping astronauts, and everything is running like a routine operation. And that's the key word here, routine. Because in spaceflight, being boring is actually a good thing. It means the system works. Then there's the Falcon 9. These launches are happening so often that now people almost don't notice them anymore. But what's really impressive here is the boosters. They're flying again and again and again, landing on drone ships, landing overseas, setting new records for how many times a single booster can fly. And what this shows is something really important. SpaceX isn't just launching rockets, they built a system that can repeat the same mission over and over, and it's all about reliability. When you look at NASA's situation right now, with the SLS delays and Starliner being grounded, it really highlights the difference, because access to space isn't just about big rockets or big plans, it's about how often you can fly, and how dependable your system is. Right now SpaceX is the one smashing it, and they're showing you how to do it. So things are looking very interesting for NASA at the moment. Hopefully they can get over this hump and they can improve from these delays and we can actually see the launch. But anyway, that's it for this video. Thanks again for watching and I'll see you in the next one. Take care.